Today we're going to look at lesson 5.4, solving special systems of linear equations. So we're continuing the system of equations, but we're going to look at special systems. So the essential question says, can a system of linear equations have no solution or infinitely many solutions? So just as a quick review, when using the graphing method to solve systems of linear equations, how do I find the solution? So really I could have asked, when using any of our methods, how or what is the solution to the system? And please don't say an ordered pair, because I know it's an ordered pair, but what does that ordered pair represent? What is the solution to these systems? The what? The point of intersection, all right? So this is especially important when you're using the graphing method, because you've got to know, once you've got the lines graphed, what are you looking for? What is the solution? So the point of intersection, okay? But let me ask you this, and I want you to think about it. What if the lines never cross? Well, what type of lines have we learned about this year that never cross each other? Parallel lines, all right? So what if your two equations are parallel lines? What if the lines turn out to be the exact same? What if one equation is in standard form and one equation is in slope-intercept, and when you graph them, they're the exact same line? So one line is laying on top of the other line. Well, what is the point of intersection? So these questions lead us into the following definition. So fill in your blanks. One solution, no solution, or infinitely many. Intersecting lines are going to have one solution because they cross at one point. Parallel lines, when the lines don't ever touch, what's the solution? Is there a solution? No. If the point of intersection is the solution and the two lines never touch, then there is no solution. So parallel lines are no solution because they never cross. And then what happens when the lines are the exact same lines and one line is laying on top of the other? Is there one point of intersection? No. How many points of intersection are there? There's a lot, right? So infinitely many solutions because they cross everywhere. So fill in those blanks, and then we're going to look at example number 1. All right, example number 1 says, solve the system of linear equations. Now, do they give us a method that we have to use in these directions? No, they do not. All right, so that means that we can pick any of the 3 methods that we've learned. Now, we are not going to get our phones today, and we are not going to do any graphing. But I want you to know this. If you're doing your homework tonight and you would like to graph, all right, if that's the method that you would like to use, I'm okay with it. You might want to grab some graph paper from me if you don't have graph paper at home. But just remember, just plugging the lines into Desmos and writing down the answer is not going to be enough. If you choose graphing, you have to actually graph the 2 lines on graph paper, and you'll have to put them into your notebook, all right? So graphing is one of our methods, but we're not going to use it in class today. Today we're going to continue getting good at substitution and elimination. So look at letter A. Now, just like yesterday, there's no right or wrong method. Both methods will work. The question we want to ask is, which one is the problem set up to use more easily? So look at letter A. It says x plus y equals 3 and 2x plus 2y equals 6. So my question, which method is this problem already set up to do more easily? Elimination, all right? Because both of these equations are written in what form? Standard. And we learned yesterday that in order for elimination to work, the problems would need to be in standard form. And since they both are, let's just go ahead and use elimination. Substitution would not be wrong, but it would make more work for you. All right, now, which variable are we going to eliminate? And again, yesterday we learned there might be a better option, but neither option is wrong. So are either one of these variables going to be easier to eliminate than the other? No, because neither variable is already set up to be eliminated. Neither variable has one positive term and one negative term. And both variables have at least one coefficient of 1. So really, there's not a better choice here. So we just need to pick one. Which one do we want to eliminate? All right, let's eliminate x. Now remember, we have a coefficient of 2 that we can obviously see. What is the coefficient of the other x? There's an understood 1. So in order to eliminate, we need coefficients that are the same number but have different signs. So what is the common multiple of 1 and 2? 2 is the common multiple. So which equation, Caitlin, will we have to multiply and change? The first one, because 1 is not the common multiple that we need. Now, 1 times what will give us that common multiple? 2. So we're going to multiply this equation by 2. Now, someone keeps saying negative. All right, we weren't there yet, but now let's talk about why they keep saying negative. If our signs are exactly the same, don't we need to multiply by a negative number? Yes, because we need one of our signs to be a minus sign. So he is correct when he says we're going to multiply by a negative 2. Now, let's bring down the equation that we don't have to change. So we're going to bring down 2x plus 2y equals 6. And now we need to multiply. So Jakari, when we multiply through by negative 2, what do we get? Negative 2x minus 2y equals? Good. Remember, when we multiply, we have to multiply every single term. Now, is the y ready to be eliminated? Class, yes or no? Yes, so we cross it out and then we begin working vertically. What is 2x minus 2x? 0. So typically we don't have to bring a 0 down, but since there's nothing left on the left side to bring down, we have to bring down the 0. And we have to bring down, of course, the equal sign. Now, what is 6 minus 6? 0. So we'll circle this. We won't box it because it's not our final answer, but the variables are gone. Both of them. So the question is, are we left with a true statement or a false statement?
True statement.
True. 0 equals 0. So if our statement left is true, what is our final answer?
Same lines.
It's the same lines, which makes our answer what? Infinitely many solutions. Infinitely many. So in this case, we're done. There's no variable that we have solved for, so there's no number to plug back into the other equation. There's no ordered pair to put down as a final answer. This is an infinitely many solution problem. Letter B. Which method would you say this problem is set up to use most easily? Why substitution? Anj, go ahead. Y is already isolated. So let's do what we did on the bell ringer last week. Let's go ahead and highlight that Y. Since it's already isolated, let's highlight it so that we remember this is what we're going to plug into the other equation. We're going to plug what Y equals into the other equation. So let's bring down the equation that we're going to use. And we're going to use 2x plus 2. Now remember, we plug things in parentheses. What are we plugging in place of Y?
Negative x plus 3.
All right, remember, it's expressions that we're plugging in, not values. All right, in substitution, we're going to be plugging in expressions for these variables. So we are plugging in negative x plus 3. And then, of course, we would bring down the rest of the problem, which is equals 4. The substitution, we've really got to pay attention to don't call me after midnight. So the D in don't stands for what? Do we have, Desiree, the distributive property in this problem? Yes, what are we going to distribute? 2, right here. So Desiree, go ahead. I'm going to bring down 2x, and then what do I get when I distribute the 2? Good, negative 2x plus 6, and of course we bring down the rest of the problem. Now, call. What's the C in call stand for? Jeremiah? Combine like terms. Our like terms in this one are 2x minus 2x. What is 2x minus 2x equal? 0. So we can actually cross this out and just bring down 6 equals 4. Now again, we'll circle it. The variables are gone. So the question is this a true statement left or a false statement left? This is false. 6 does not equal 4, which makes our final answer what? No solution. So that means if we graphed these two lines, what kind of lines would they be? They would be parallel lines. So no solution. Again, I've got no variable solved for, nothing to plug back in, no ordered pair to give. The final answer is no solution. Now let's look at letter C. If we're looking at letter C and we're trying to pick a method, which method is this equation set up to solve the easiest? What is it? Elimination, all right? And if I were you and I saw this question on a quiz or a test or a homework and I was picking, all day long I'd pick elimination. However, we're actually going to do substitution on this one for the sake of our notes, all right? And here's why. You did substitution in your flipped classroom last Thursday. When you practice substitution on Friday in class with me, every single problem I gave you already had a variable isolated. But what happens if your quiz on Friday has a problem that looks like this and it says use substitution? I want to make sure that you learned what you needed to learn in lesson 5.2. So in your notes right now, we are going to do substitution. But again, if you're on your own and you're getting to pick, absolutely I would pick elimination. All right? Now I need you to think back to lesson 5.2. What's the first thing I told you to do? If one of your variables was not already isolated, I told you to label these as what? A and B. All right, so go ahead and label A and B. Now, we have to pick either A or B, and then we have to pick a variable to isolate. So, Haley, which equation would you like to use, A or B?
A.
All right, let's do A. So we're going to pull A over to the side, and we're going to do x plus y equals 3, and then I'm going to cross out A so I don't try to use it again. And Haley, which variable would you like to solve for? Good. Either would work because both have a coefficient of 1. So there's no right or wrong answer here. But Haley, if you're going to solve for x, what do you need to move? How are you going to move it? We're going to subtract y from both sides. Now, be very careful. What does x equal? Very good. These are not like terms. I can't combine them, so I bring them down separately, and we like to bring the variable term down first. Now, what letter am I going to label this one? C. This is our third equation. So, we have isolated the x, so I'm going to go ahead and highlight the x just to show what I've isolated. Where am I going to plug the value of x? Into which equation? B. All right, we labeled it B, so we're going to plug the value of x into the B equation. Now, right off the bat, x is at the beginning, so I'm going to plug in negative y plus 3. And then, of course, I'm going to bring down the rest of the problem. Is there any distributing to do in this problem? No. So we go straight into what step? All right. Maya, good job. What are my like terms in this problem? Negative y and 2y, and there's actually a what in front of that negative y? An understood 1. So Maya, what is negative 1y plus 2y? 1y. You can put the 1, you can leave it off, but then we bring down the rest of the problem. So plus 3 equals 4. Now, what's the only thing left to do to solve for y? Subtract 3 from both sides. So what does y equal? 1. Now we circle it, we don't box it. We also are going to cross out the b because we've used that equation. So where is the most logical place for us to plug that 1? Back up into C. So x equals, be careful, there's already a negative in the problem, so make sure you bring it down and you're only plugging in a positive 1. Okay, the negative is from the equation. Bring down the plus 3 and let's solve. What's negative 1 plus 3? 2. So the final answer is what? The ordered pair 2, 1. Leads us into our very last problem for today, and it's a word problem. It says, write and solve a system of equations to find the price of 1 cup of dried fruit and 1 cup of almonds. Now, I'm going to have you work with your partner first to set up the equations. Then once we make sure everyone has the right equation, then I'm going to have you actually solve it with your partner. But let's talk about the problem before I have you work. It says a small bag of trail mix contains 3 cups of dried fruit and 4 cups of almonds, and it costs $6. So the bag itself costs $6. A large bag contains 4.5 cups of fruit, dried fruit, and 6 cups of almonds, and that bag costs $9. Now look back at what you're trying to find. You're trying to find the price of 1 cup of dried fruit. So what variables make the most sense for us to use? If we're talking about dried fruit and we're talking about almonds. D and A, okay? Or I heard F and A, all right? F and A is probably even better because we're talking about fruit. All right, so let's use F and let's use A. We don't need x and y because we're not actually going to be graphing this. So we can use the f and the a. All right, work with your partner, set up the two equations, and then stop. What is the first equation that you got with this information?
3f plus 4a equals 6.
3f plus 4a equals 6. Good. And what's the second equation?
9 over 2f
9 halves f plus 6a equals 9. Very good. Now these are your equations. This is your system. So now I want you to work with your partner, choose whichever method you guys decide on, and solve for f and solve for a. Which variable makes the most sense to eliminate? A. All right. I would not work with fractions if you don't have to. Decided that we were going to eliminate the a, so we're looking at 4 and 6. What is the common multiple of 4 and 6? 12. All right. Are there other common multiples of 4 and 6? Yes. 24, 36. But 12 is the best because it is the least common multiple. So 4 times what will give us the 12 that we need? 3. So we're multiplying the first equation by 3. And then 6 times what will give us also the common multiple of 12? 2. So the second equation is going to be multiplied by 2. But before we start multiplying, we've got to ask, are we able to leave both of these numbers positive? No, because my signs are the same. Does it matter which number I make negative? No. So let's just make the 3 negative. All right, Maya, when you multiply the first equation through by negative 3, what did you guys get?
Negative 9f
Okay.
minus 12a
Mm-hmm. Very good. All right. Jakari, when you guys multiplied the second equation through by 2, what did you get?
We did all different.
All right. Did somebody multiply by 2? All right, Haley, what did you guys get?
9f plus 12a equals 18.
9f plus 12a equals 18. All right. Right here, remember, a whole number is the numerator and this 2 is the denominator. So they cancel. Or if you multiplied, 9 times 2 is 18 and 18 divided by 2 is 9. Either way you did it, this right here should have come out to be a positive 9. Now, the a's, are they ready to be canceled? Yes. And when we begin to work vertically, what happens to the f?
They cancel.
It cancels, so 0 equals, what's negative 18 plus 18? 0. So once again, the variables have disappeared. And do we have a true statement or a false statement? So what's our final answer? Infinitely many solutions. Now, I will be honest, this threw me off at first. I'm like, this is a word problem. How do we have infinitely many solutions? But if you think about what you were trying to find, it would make sense. You were trying to find the cost of 1 cup of fruit and 1 cup of almonds. There's a lot of different number combinations that would allow this to come out to equal $6 or $9. So when you think about it in the context of the problem, it's not that far-fetched that there's a lot of different answers. All right, so that is lesson 5.4.